Good morning, everyone. So, I've had lots of requests to do Bluetooth stuff, so that's what we're going to dive into today. Slightly different format. I need to keep my mental up. What's going on at the moment is tough. So, yes, let's hide my disgusting face because that's going to get in the way, and let's dive into some Bluetooth. So, just pull up the notes. There we are, lovely. So the way BLE works is quite layered. There's other videos out there really that will do a much better job of explaining how it works. But for us in the ESP world, the basic layer, the very sort of lowest layer above the actual controller itself, is called GAT. Now we're going to start higher up than that. Sorry, GAP. Did I say GAP? On top of GAP sits GAT, which yeah, it's confusing. GATT is the sort of highest level, and that defines all the services, characteristics, and so on that you might be used to seeing, where you can get your heart rate from a watch and all that sort of thing. So without further ado, I suppose let's get rocking and a rolling. So I'm going to create a folder. Let's call it BLE. Seems as good as any. And in that, I'm going to create a folder called GAT. And then in that folder, we're going to create a file. So it's going to be, let's call it service base, and this is going to be a header file .h, whatever. You know we work in C++ world here. Actually, let me go full screen there. Lovely. Okay, so I'm going to first of all copy in a bunch of headers. So I'm just going to copy this straight over from my notes. We may not need some of these, actually, thinking about it. C standard int, C string, yeah. Yeah, I don't think we'll actually need those, but we'll see how it goes. ESP error, always useful to have. As you know, we tend to return error codes from functions in embedded land, so that's what we'll be doing here. Now these includes are all from the IDF, and they sort of define or describe what's going on with the various layers of BLE and how we can interact with them. We'll see more about what's in these fairly soon. So let's actually write some code. So namespace, let's call it GAT. Seems like a good start. And then personally I always like doing that. Oh, have I got auto format turned on? That's going to drive me bonkers. Anyway, we'll go with it. Now, in a GAT service, we can have a bunch of different characteristics. So in the service, we could have a heart rate service, for example. We could have heart rate. That would be a good characteristic to have, you would think. But we might also want other things, like where that was measured. Is it measured on the chest or on the wrist, so on and so forth. So that would be a characteristic, a bit of information. We may have another one that is, for example, the expected error on that calculation. We could have, all sorts of different things in there. To give a slightly different example, devices tend to have the device information service, and within that you may have a characteristic which is the manufacturer's name, another one that is the model number of the device you're talking to, another one, that is the friendly name of the device, a sort of human readable name, as it were. There may be a date code in there of when it was manufactured, a firmware version, hardware version, all these different characteristics. So how are we going to do that? Well, you might think we could just have a class, or could well be a struct, of course, and in that we're going to have some sort of table or an array. So I suppose let's go down the standard array route. So let's do this. So standard array, and then we hit an issue. So these arrays are going to effectively contain pointers to data that may be stored elsewhere. We may store it here. Might be a good idea to store it here, you would think. But actually what really happens is it is stored in the API, in the actually in the controller, and we get back a bunch of pointers. So let's, for want of a better thing at the moment, we're just going to get some pretty raw pointers, and we're going to need one of those for each of the characteristics we have. But how many is that? Well, we don't know. Let's just put p characteristics here just so you can sort of see what's going on. Well, for a device information service we may have 8 different bits of information, for example. So device name, manufacturer name, firmware version, hardware version, serial number, and 3 more, largely irrelevant. But for the heart rate service we may only have 1 or 2 or 3. Well, we need to know what this number is, because it's a compile time number, because as you can see it's within the angle brackets of the template. So we actually need to pass this through. So this makes this class a template class. Template, have I spelled that right? Yes. And we're going to have, you would think, a standard size T of n characteristics. I can almost spell. Okay, great. That seems fairly logical. I can tell you now that is actually not what we'll be doing, or very slightly different to what we'll be doing, because we also have to tell the API when we create the table in the Bluetooth controller how many entries there are in this table, and that API expects a uint16, not a size T, which in this case is 32-bit, so 4 bytes. So it makes actually a lot of sense to make this a uint16. And I suppose if we were being hyper correct, we could do something like that. Can you do something like that for a uint16? I can't remember. Let's stick to what I know. Now there is a caveat on this. In the table, when you read the documentation for the IDF, a characteristic uses 2 rows of a table, of a predefined table. However, a notification, which is a slightly different mechanism but very similar in BLE world, actually uses 3 rows of that table. So our table is going to be a different size depending on how many characteristics we have and how many notifications we have. And a notification is something that can push data, so it tells a connected device that a characteristic has been updated and get the new value, whereas a raw characteristic has to be effectively manually read to get any updates, and you don't know if that number has changed until you read it again. So we actually need a second bit of information here, and let's just make it a uint16 again for the number of notifies. We may not use this, so if that's the case we can default this value to 0. And as I said before, we need 2 rows in an array, as by the documentation that Espressif give us, per characteristic, or 3 rows in the array for a notification. So this value here is actually 2 times n characteristics, oops, forgot an underscore, plus 3 times n notifies. Let's just make sure I spelled those right. Yeah, I have. And this is starting to get rather unwieldy. So we might actually want to just break this out into a class member. And we can actually do that quite easily. Static const expr table n rows is that. Cheers auto format. Can I turn that off? Format on paste, format on save. So just fixing this as I go, because that is going to drive me mental. Have I got Clang format set up? I have. But that shouldn't be getting called unless VS Code calls it. What I'm looking for is format on paste, because that's what just happened, but that's clearly disabled. Oh, blow it, I'll fix that later. For now, you'll just have to see me get more and more mad. So, now we can just put... Oh, I don't want to do that. Oh, it was fine, it was fine. Now, this is fine to do as a static const expr, because for each instance of this template, as long as these 2 numbers are the same, for that particular instance, which they will be, then this value will be correct. If we do, for example, create a GAT object that has 5 characteristics, 0 notifies, that will provide 10 here. So 2 times 5 plus 3 times 0, so that's 0. If we make another one that has 2 characteristics in it, that will actually stamp out another copy of this class that will be sort of mutually exclusive, for want of a better word. And in that case, for 2 characteristics, this value will be 4. So it'll be 2 times 2 plus 0 over here. And then if we create another one that is 5, so we happen to have 2 GAT instances that both have 5, it will just use the previously stamped out version that has this set to 10, because 2 times 5. So this works quite nicely. That's sort of a little bit into how templates work. This is a bit of a placeholder for the moment. Okay. The most important thing, I guess, I'm trying to figure out in my head the best way of actually doing this, because I've got working code on my other screen, of course, but I want to feed it to you in a nice way. Okay, right, I know what we'll do. So there's a couple of bits of information that this class needs to have that will be different for every instance, so they will be member variables, and they will be constant. Will they be constant? That's a good question. Bear with me a mo. UUID primary is what I'm looking for. Yes, that's primary. And table ID, sorry, ID. Yes, they can be constant, right, okay, cool. Before so these can be public because they're constant. Yeah, let's go with that. Okay, so each service will have a unique identifier, or a UUID is how we call it. These will be constant for the service, and they will be different for each service, so they won't be static. And we actually have a type that we can use, UUID _T, and this will be our primary service UUID. Now, that's not how we will refer to this in the API. The way the API does it is when we create the service in the API, it will give us an ID, a number, an integer. Actually, in this case, a uint16. Does it give us, or do we tell it? I think we might tell it, actually, off the top of my head, I forget. But that is how we refer to it in the API. We give it the ID, the integer, of the one that we mean when we want to, for example, change a value held by a characteristic in normal runtime. So we'll just call that ID, and that happens to be a uint16 in the API, so we'll keep that constant. Now, as these are both const, we must initialize them. We can't do inline initialization because we don't know what these are until the constructor is called, so therefore we must initialize them in the constructor. So let's do const esp bt UUID type UUID. We can have the argument as to whether or not that const should be there. Personally, I prefer it there. I think it shows intent better. Maybe it helps the optimizer. I don't know. There is argument on that. uint16. And because we're in the constructor, we can give it a slightly nicer name. Service UUID, like that. And then, of course, we need to initialize these. So primary. Oh gosh, I can't type today. Sorry if it's very clacky. I've got a new keyboard. Service UUID, and then ID will be table ID. Thank you, IntelliSense. And then actually we don't need to do anything in the constructor at the moment, so that can effectively be a no-op after we've done the initialization here. Okay, so that's these two initialized. That's good. Still need to do something with this though, which we'll see in a bit. Okay, so can I show you how the service looks in the API? That might be useful. So let me just pull up interwebs and go to BTLE. GAT we want, GAT server we want. So let's have a look at this. Sorry as I just zoomy scroll through this looking for what I want. I don't think this is documented particularly well. So, okay, you know what? It might be better show an example. So let's go to their GitHub. It's an event handler. That's Gap stuff that we'll talk about later. It's the attribute tab. That's your callback. What I'm looking for is what the table looks like. Oh, have they changed this? They have. This looks like it's changed. As in they've changed the example. The format is still the same. Let's just Control F that. Yeah, they have. It's here. Right. Okay. Forget that idea. We'll do it. We'll do it my way on the highway. Okay. So right. You can tell I'm distracted. I'm so sorry, guys, but it is what it is. Now, we've talked about the service UUID, so that is the unique identifier for this particular service that will be broadcast over BLE. Now, the way BLE or GAP works is that each record in the table has an identifier that tells you what the next bit of information is. So, for example, right at the start of the table is normally an identifier, which is pre-known from the standard, that tells you that the next bit of information you read is the unique ID of the service. So, for example, let's hypothetically say that unique identifier is 1. And then our next bit of information in the table is the service UUID. Then we might have the next identifier is 2, which is our first characteristic. So then that will say the next bit of information will be the characteristic UUID. For example. Then the next bit of information might have identifier 3, which says that there is a bit of information within this characteristic. So let's say this is heart rate, and then we may have another 3, which is another bit of information that is body position. But actually, let's say 3, this identifier here, means it's a notify rather than a characteristic, because we want to get, we want our phone, for example, to be told when our heart rate changes. But we don't necessarily need to tell it when body position has changed, so this might be a different identifier here. You'll see where I'm going with this in a minute. Then we may have another characteristic within this service that is something completely different, say the device information, or something about device information. So this will be identifier 2 again, because this is another characteristic. Sorry, I've missed something here. Oh, I knew it was going to do that. Right, ignore all of this. I've not used VS Code in too long. Was it? There we go. That's what I wanted. There we are. Almost. Almost. There we go. So we may have another characteristic. So, oh, you are driving me mad. Which is, let's just hypothetically say, it's another just characteristic, not a notify. So actually, I should probably change that. Technically, there's no difference, but we'll see how it's defined slightly differently. And this could be our firmware version, for example. So you can sort of see how this table is built up. It's a load of pre-known identifiers and then a bunch of information following it. Now there's actually more fields in these, because in this case body position, that's a bad example, so let's just make another one. Let's say user age, which is going to be a 4 because it's just a bit of information. So I'm typing this because I don't dare paste and send it mental again. Characteristic age, and then to support that we may get a characteristic UUID, which is your I don't know, not your BMI, that's a bad example, but your what's it, your calculated age. I forget what the term is used, but basically they can, yeah, there's a formula that says, well, if your heart rate is this and you're this old, then this is how old we think you should be, you know. So if your heart rate is really, really bad, you know, you're going to appear older than you are. If anyone had a Wii Fit and things like that, you'll know what I'm on about here. But the point is that this information is not provided by the device. It's actually provided by the user. So this is a writable thing, whereas this is a read thing. And this is read, this is read, this is read. And actually, it's not just the bits of information, but the UUIDs can't be changed by your phone as well. So these are all reads as well. And you get the point. I could fill out all of these, but you can see that actually we need this extra bit of information to say whether it's readable or writable. And actually there's a few other bits and bobs in there too, which we'll see as we go along. I won't fill out this table anymore, but you can sort of see that, you know, there's stuff we need to know. That's going to drive me mad. Anyway, whatever. So we used 1, 2, 3, 4 for these statically known, defined by the standard identifiers for what the next bit of information is going to be. They're not 1, 2, 3 and 4 in the real world. They're actually defined by the standard, as we say, and they are hex numbers typically. In fact, they are all hex numbers. And we can actually fill some of these out. Now, the API gives us some types. In fact, we actually already know these types. It's just a UUID. So we have a UUID type, which is the primary service UUID. And this UUID is actually a structure. Can I have 12 into this? No. That's because I've not built it yet. But anyway, take my word for it. It's a structure that the first bit of information is how long the UUID is. They can be, I think, 8-bit, 16-bit, 32, 128. So you can get short hex codes, long hex codes, and so on. Most, if not all, of the predefined by the standard ones are all 16-bit. And there is just a hash define in the IDF for this. UUID len 16. ESP UUID len 16. And then the next bit of information in the struct is only 2 bits. It's a pair, effectively. Again, because it's defined by the standard, we get a macro for this. Well, not a macro, a hash define. Get UUID pri service. And you can look these up if you wish. And let's just put a bit of formatting in here to make it look a little bit nicer. Why bother doing that rather than just use the hash define? C versus C++ argument, basically. As far as I know, this actually puts that value into the flash memory once, using the one definition rule. I don't know if that is true for hash defines, whether they are subject to the ODR, the one definition rule. I don't think they are. It might not matter either. I'm not sure. Maybe someone knows and can put that in the comments below if you do know that. So that's the primary service. So that is the UUID of our service. It tells the user, this service is the device information service. This is the heart rate service. This is the time service, whatever. There's a few more. So let's actually do a few more. You know what, I'm just going to take the hit. Let's just spam a few of those down like that. I'm going to have to sort this out. That is driving me bonkers already. So, what else have we got? Well, we saw that we need a UUID to say that the next bit of information is a characteristic description or a characteristic. And there's actually a few different ones here that we can talk about. So, car declaration, let's say, which is car declare. So this says the next bit of information is going to declare declare or define? Yeah, declare a characteristic. So there we go, we've got that now, as we can do. I'm doing these as free sort of free variables. Well, they're not variables, free constants, globals effectively. We'll see the other way of doing this in a minute, and it's a bit of a toss-up as to whether that's better or worse, but we'll discuss that in a moment. So there's a couple of others. Let me just fill these in quickly. Client config. This is what the client uses, so your phone, to say, yes, I want to subscribe to a notification. And let me just, you know what, that's a long one, so I'm gonna just quickly copy and paste these in from my notes. So this one is a property that says this thing is read only. We can have one that is a property that says you can read and you can write to this. And actually these are a different data type, so I've already messed up here. This is a gap permission type that only contains that number. So let's just copy and paste that down a few times. So this property can only be read, so like the heart rate we saw in my little example earlier. This one is read or write, and these are actually just bit fields, so we can OR them together like that, which is quite nice. This one is a read with notify, and again we can actually just OR together the read property with the notify property. I don't know if read write notify makes any sense. I've not got it in my notes here, so I've not used it, but that could be there. So let's just sort of do a bit of organization here. So these are UUIDs, these are properties. And we now need some functions to actually create a row of this table which contains all these bits of information. Now the IDF gives us a way of a data type that we can use, which is an attribute database _t, which gives us a row of the table. So let's just call this create get table row. And what do we need to pass into well, first of all, what do we need? So actually, you know what, I'm just going to copy and paste this in and then we'll talk about it. So get auto response, that is pretty much what you'll always use. That is in the notes, the API guide. This is pretty much always what you want there, so we can just roll with that. The next bit is the length of the descriptor UUID, which is this, and then the actual UUID itself. So we've seen that here, it's just this structure effectively. Now we don't know which row this is, so what we're going to do is pass that in. So we'll do a const, this is going to have to go in by copy, but we can do a const ref to descriptor. Let's just call it descriptor for now. And we want descriptor.len, which is this isn't a standard pair because it's C. It's just a struct that contains len, and then actually a union of the different UUIDs it could be depending on the length. And we can actually just sort of brute force that a little bit by making it a pointer. So yes, I don't like that, but and this could be a static cast actually. Let's make it static cast. Let's stay in C++ land, shall we? There we go. So the permissions, well, it depends which one of these we want. So we're going to have to pass that in. Which is going to be a const esp get perm type, and that goes straight into this table. Oh, actually, does it? No, I'm chatting rubbish. We're creating a get table row that is a declaration in this. No, I'm right. I'm being a dum-dum. There we go. Yeah, we're going to pass. This is generic. That's the whole point. I want this to be generic. So in go the permissions, and they go straight into this struct that is this data type here. Now we need a couple more bits to go into this. You'll see these random size ofs. If I remember correctly, one of them is no, I have actually forgotten. Have I forgotten? One is the size of the it's the size of the next parameter, I think. And then this one is the size of the data held, or the length of the data held in this pointer. That's what it, yeah, I think think that's right. At least these two are right. That one I can't quite remember off the top of my head. So this is effectively the length. So what we need to pass in here is some data, and that's what our characteristic is going to hold. And actually this is probably going to have to become a template because of that reason. Because this might hold different data. It may hold, so in this case, the property. It might hold a perm. Have I got my naming wrong? Because there's actually a... I'm sure there's a property type. We'll come to it. Yeah. But we may want to hold, you know, a float, a uint 8, a uint 16, an int 8, an int 16, blah blah blah, a string, so on and so forth. So this becomes size of t, and then this will be a static cast. In fact, exactly the same of this, because the API expects bytes, raw bytes, or a pointer to the start of the memory where this number of bytes is held. So that makes that fairly okay, fairly straightforward, hopefully. And then we're just going to have a const t and to the data, like that, and then that becomes data, like that. So when we use this, what we're doing is we're converting a bunch of information into a row of our table. So we need the UUID that describes what this row is. We need the permissions of the row, so whether it's readable or writable, and so on. And we need the data. The only one I'm unsure of is that, but we'll figure that out next episode. Well, in between episodes, and I'll come back to you. And this returns a row of that table. Lovely jubbly. So I've done that as a free function. Makes sense to be a free function, I think. And there's a good chance that most of this will be known at compile time. So this can actually be Mark's const expr. And really it can be no accept as well, because it doesn't allocate any memory. Yeah, happy with that. Cool. Am I happy with that? Yeah, I'm happy with that. Alrighty. So, let me just scroll through my notes again. Right, got you, okay. I don't know why it's auto indenting that after a template, that's really annoying. But anyway, so we still need this. We still need this array. Now, before I said it was this number of rows. I actually slightly lied. I missed one off. The service itself, with the service UUID, needs its own row as well. So it's actually 1 plus 2 times n characteristics. I can put this in brackets if you prefer. Not that it makes any difference, apart from visual. But that looks a little bit nicer. So that's the number of rows. It's a pointer to a bunch of bytes. I don't know whether we could use standard byte here. I'll say I've tried standard byte twice and didn't like it either time. I I still do prefer that. As nasty as that can be. And actually, no, this is wrong anyway, because, and we know this, because a row of the table is actually one of these. So a table consists of those. Make sense? And we have that many rows of these things, which we can create using this function here. Yeah, that is what I want. Okie doke. So we can actually just fill in a little bit of stuff now into this table. And we can potentially do that in the constructor. In fact, it probably makes... Does it make sense to do it in the constructor? It does if this becomes const expr. Let's see if we can do this. This is going slightly outside my notes now. So, what we can do is, let's actually change the name of this. This is our table. And I would prefer that to be private. For now, we will actually change that to protected, I think. Maybe, in the future. So the first row of the table, I've already sort of said, is the service definition. So we can create that by creating a row. Which takes the primary service UUID, what was the next bit? The permissions, which is going to be slightly confused. I think I've done this wrong. I think I've got, because I can't F12 into that at the moment. You know what? Let's fix this, because that's gonna, I don't want to mislead anyone. So let's have a look here. Yeah, there is another one, prop T. Yeah, I have got that wrong. Okay, cool. So let's fix that. So these are properties. And then we do need permissions. Oh my god. Static const. As far as I'm aware, there's no value in making those const expr. So car read, and then for the moment we're only going to be using read properties. But we'll expand this as we go, because I need to tidy this up anyway. As you can see, it's getting a little bit unwieldy. So the second parameter to this function we've created is the permissions. So Padink, knew it was going to do that. Why do I bother? And then the next one is actually the data, which is the service UUID, which we have here. So we'll pass that in, and that gets passed in by constref. Notice that I'm passing in our class instance of this, because then that allows the user, because this is passed by copy, if this gets destroyed, because we're taking a pointer to it, then that becomes the dangling pointer, which is bad, very bad. Don't want that. whereas this is valid for the lifetime of this object, which we will assume, and we'll make sure we document, this has to live as long as longer than the API using it lives. God, I can't even English. Anyway, you know what I mean, hopefully. So that's the first row of the table. And that will always be this. It will always be the service UUID with a read permission, because, well, you need to be able to read what the service is on the end device, and then the actual thing itself. Now, because that is a templated function, the lengths and everything all get sorted out, which is quite nice. And that gets done for us. Now, as for the other rows in the table, so the next row might be, our heart rate or our firmware version. It'd actually be the declaration of the firmware version, and then the next row would be the actual number itself. But we don't know what they are in this base class, so we can't actually fill those out yet. But we will be able to soon. Next episode, though, probably. So that sort of creates the table. Now, the last thing we actually need to do is send this table to the API. This also doesn't create memory. Allocate memory shots, sorry. So that can be no accept. That's not the only rule for making something no accept, by the way, but in this case that is valid. So we will need to actually create the table. So this is where we'll be calling the API. So create table, and we will need to pass some stuff into here, but we'll see that when we get there. Let's just put some boilerplate in. Okay. Now, it says in the documentation that you don't want to create the table more than once. Well, you probably don't want to create it more than once. So we actually need to keep tabs, bad word, on whether or not we've already called the API. So and then we can just do a conditional on here. So if not created, I think you can actually do, yeah, you can, if not created, then we will call the API. We'll just do an OR on that. And the API call is ESP BLE GAT server create attribute table, and we pass in our table, which actually expects, I think, a uint8 pointer. Let me just double check. No, it expects a point. Hang on. Let's just put some scoping on this because this might get messy. It's going to get messy if it keeps doing that. This is going to take one of those, which is p data. Let's just call it that. Now we've used a standard array here. Obviously, the API written in C won't take a a C++ standard array, but we can just get the raw pointer like that. And that is going to take pointer to the actual data, and a standard array is guaranteed to be contiguous and so on and so forth, so that is valid to do. I of course could just put table.data here, which I might change it to, but I don't know, we'll see. This will get optimized away anyway, so it doesn't really matter. The next parameter it takes is the GAT server interface. Now we've not talked about that because that's a lower level and we're starting reasonably high up here. Not quite at the highest, but almost. So that is the GAT's interface that we're talking to in the API. So we're actually going to just pass that in. GAT if type. And we'll just pass that in, and that just gets sent straight through. And then we want another conditional here, unfortunately. To set our little flag here. Oh, table created. GG, anyone who spotted that. So if we've not already successfully created the table, create it. If that returned ESP OK, so succeeded, then we'll set our flag to true so we don't then recreate it. And then we return the status, which should, you would expect, return ESP OK unless there was a failure in the API. If there was a failure, we won't set our flag to true because it failed, and we'll return that failure. If the table is already created and the user of our code tries to create the table again, it's just going to return ESP OK and not do anything, which is the behavior we want because it's already created, so everything is okay. That's what we sort of expect. Now we can't mark that no accept because we don't know what goes on behind the scenes in there, so we won't do that. It can't be const expert because again we don't know what's going on behind the scenes there. Almost certainly runtime stuff. So we created the table in the IDF. Last thing to do actually, or yes, there's two more things we do need to provide in this class, and that's a way to start the service. So we've pushed our table to the API, but the API hasn't actually made it available yet to BLE until you start the service. So we will need to implement that, but there's actually a few other bits and bobs we need to do to be able to do that. And then of course we want a way of changing data in this service. You know, if we've got heart rate in here, we need to update the value that the API holds for that, and that requires some stuff that we need to do as well for the start service, which we'll do in the next episode because this is sort of dragging on. I need to fix the formatting, auto format stuff, and straighten my head a little bit. But that's a start. Okay, that's a bit of a start. I don't know when the next episode will be. I'm going to try and do these regular, but with everything going on at the moment, yeah, we'll see how it goes. Hope you enjoyed, and look forward to the next one. Questions, comments and so on down below as per usual. Cheers guys, stay safe.